Bismillah ar-Rahman ar-Rahim. Let's look at this problem. Draw the shear moment diagram for the beam. So this beam is shown. It has a triangle loading here, and here there is like a rectangular loading, and there's another triangle loading. And you can see that there is a ruler here, and there is a pin here. This ruler will have one reaction in the Y, and this pin has one in the X and one in the Y. So there's two reactions here and there's one reaction here. It's 3 feet from here to here, 6 feet from here to here, and 3 feet from here to here. So let's analyze the loading of this beam. Okay, so we'll analyze it like this. Remember, he said that it's 600 pound per feet. It's 600 pound per feet for this rectangular, and 600 pound per feet here, and then going linearly to 0 to this side. Same thing from here, 600 from here and going down to 0 at this side. So let's analyze this beam. Okay, so you're gonna draw it like that, and then we're gonna find the forces. Look at this triangle. This triangle, it's 3 feet, this is the base, and you can see that this one is 600. So this one, this side of the triangle is 600. So 1/2 times 600 times 3. It's, what is it? 300 times 3, that's 900. So 900, it should be 1/3 of the base. So it's going to be like this. So 1/2 times 600, that's 300, times 3, that's 900. So it's 900 pound, because pound by feet times feet, it's pound. So it's 900 pound. And the location of this force for this triangle, it's 1/3 the base. This is the base. This is the base. 1/3 the base. So 1/3 the 3, it's 1 feet. So it's 1 feet from here. And of course, since 3 feet, it's 2 feet from the other side. You could do for the other triangle too. The other triangle is 600 feet. So it's 1/2 600 times 3. That's the same thing. It's 900. And it is this is the base here. This is the base. So 1/3 of the base, that is 1 feet, and 2 feet the other side. So it's 900 pound, 1 feet from this side, and 900 pound, 1 feet from this side. And this rectangular is 600, and 600 times 6. So this rectangular, 600 times 6, 6 times 6, that's 36, so 3,600 pounds. 3,600 pounds, and this is a rectangular, so it's going to be in the middle of the rectangle. It's 6 feet, so it's going to be 3 feet from here and 3 feet from here. And remember, here there is one in the Y, by, and here there's two reactions. It's a pin. It's one in the X and one in the Y, AY, AX, since this reaction is called A and this reaction is called B. So we analyze it like this. Now the best is, first of all, let's find moment at point A. Moment at point A will rotate this force that way. So this is going to rotate that way around the A. So it's a negative, minus by times 6. So minus by times 6. And then this one going to rotate that way, counterclockwise. So it's a plus. So it's 900 times 1 plus 6, 7. So 900 times 7. 900 times 7. That's in the plus. We found this. We found this. Now let's find this. This is going to make it like this. It's also a plus. So plus 3,600 times 3. 3,600 times 3. And then this one, if you fix it, if you nail it that way, this force is going to make it negative. Okay? Minus 900. And you can see it's 1 feet from A. So minus 900 times 1 feet equal to 0. So you could find from this by. By is equal to 2,700 pounds. So by was found 2,700 pounds. Now, let's go and find out summation of moment at B. Summation of moment at B. So you could find out AY, because AX will be 0. AX is in the line of action. So AX is 0. Summation of moment at B. AY gonna make it like this. A positive, AY times 6. Okay, and then 900 gonna be going like that. It's a negative, minus 900 times 3 and 3 and 1. That's 7. So minus 900 times 7. And then 3,600 gonna go also negative. Minus 3,600 times 3. Then moment at this point. And this one gonna take it also plus. So it's gonna rotate the whole beam that way. So it is plus 900 times 1. Plus 900 times 1 equal to 0. And from here you get AY equal to 2,700 pounds. Okay. Now what we have? We have this force Y, this force Y, this force Y, this force Y, and this force Y. Now let's find summation of force at x equal to 0 to find that AX, there is nothing else in the x-axis, so AX equal to 0. So once we find out this reaction and this reaction, now we go and find the shear and moment diagram. Okay, let's plot it like this again. Now, we know that there is a reaction here. Remember the reaction? It was equal BY 2,700, which means that there is a reaction here 2,700. And also there is a reaction, the AY 2,700. So we have 2,700 both, BY and AY. Okay, so remember from last time, we did show that if it was linear like this, the things under it has to be a non-linear. If it was rectangular like this, the things under it has to be linear. So let's look at this. This is linear. So the shear has to be non-linear. So we put the shear like this. We should put shear as V, and we call it as bound because the shear is going to be in bounds. And of course here we start always from 0 because there's no reaction here. So we start from 0. And you go, what is the area of this? What is the area of this? Remember, 1/2 3 times 600. That's 900. So 900 down. So 0 minus 900. So you go to minus 900. You stop at this point. The relationship between 0 and 900 and the minus has to be nonlinear. So you make it concave down like this. You don't make it linear. You make it concave down. Now at this point is minus 900. Here there's a reaction, and this reaction is going up. Remember? There's a reaction here, BY, and BY is 2,700. So this is minus 900. You have to go up 2,700. So minus 900 plus 2,700, you'll end up with 1,800. So you go from minus 900 to 1,800. Now we came to this point, point P. Now remember there is a rectangular force here, and this rectangular is 600 pound times 6, that's 3,600, and that's going down. So from 1,800 you have to go down 3,600. So minus 1,800, that is not here. So 1,800 minus 3,600, you do it. So you do it here. 1,800 minus 3,600, and that would give you 1,800. And the minus, because this is going to be a minus. So you're going to go from 1,800 to minus 1,800, which means that you're going to intercept this axis here. So this is a very important point. We have to find this point. And since you can see it's 1,800, 1,800, since there is like a balance between these 2 points, one in the plus, one in the negative, you will assume automatically that it will be in the center. It's 6 feet, so it's going to be, this intercept going to be 3 feet and 3 feet. It's only because we have these two numbers, 1,800 and minus 1,800. So there is some, the triangle will be similar. So it's going to be 3 feet, 3 feet. Only for this. So we came to this point, minus 1,800 down, and now there is a reaction here, and this reaction is going up. So let's go for AY. AY is 2,700 pounds up. So you have it here, minus 1,800, and you have to go 2,700 up. So minus 1,800 plus 2,700, it will give you 900. So we are here at 900. Now we have to go down. So it's the same thing. 1/2 600, 300 times 3, that's 900 down. So you have 900 and that's gonna go minus 900, that's gonna go to 0. Eventually has to go to 0 here because there's no reaction here. But this reduction from 900 to 0 has to be non-linear because this is linear loading. The shear has to be non-linear. This is linear loading. This is, I mean, rectangular. The shear has to be linear. This is linear. The shear has to be non-linear. Now, since we found out the shear diagram of this beam, now we're going to find out the moment. Let's start. Here, there is no moment. It's 0. So you're going to start with 0 moment. Now, let's come to this point. What is the moment at this point? Let's make a cut just before the reaction. Let's make a cut. So if you make a cut just before the reaction, you're going to have this loading. And again, the loading is 1/2 600 times 3. Remember? 1/2 3 times 600. So 1/2 600 times 3. And this loading going to be 1/3 the base, 1 feet, and 2 feet from here. So let's find the moment just before the reaction. Just before this reaction. Just before the reaction. To find out the moment. So this force will rotate that way. So you need a moment the other way. So this is going to be what? This is going to be negative moment. So this is what? If this is like 900 times 1, you'll have a moment 900 times 1, which is like 900 pound-feet. And that's going to be negative. So we're going to have a negative minus 900, minus 900 this that way. And since we have nonlinear shear, you'll have a nonlinear moment. Okay, concave down, minus 900. And now, remember this. Now we're going to go from this point to the middle, to this center, because the 0 shear means that there is a maximum moment. So the 0 shear means that there is a maximum moment. So now, how could you find this moment at this 0 shear? We should find out the area under the curve. The area under the curve. So 1/2 times 1800 times 3. So 1/2 times 800 times 3. Where is this? Did I find it here? Okay. So we should do it like this. 1/2 times 1800 times 3. This is 900 times 3. That's 2700. So this is the area under the curve. 2700. So this is going to be in the positive. It's in top of the line. And remember here, the things, it was minus 900 plus 2700 because this is the area under the curve, and this is going to be the maximum moment. So when you say 2700 minus 900, you will end up with what? I just made it here. So 1/2 1800 times 3 minus 900 because 900 is here. That will give you 1800. Okay? So we got this moment. Again, 0 shear mean maximum moment. Now, this will give you also another area which give you a moment. 1/2 1800 times 3. So 1/2 800 times 3, that's minus 2700. That's going to be in the other side. That's the minus, of course. Okay? And now you have to add it to this. Minus 2700 plus 1800, you'll end up with what? Minus 900. So you're going to go from here all the way to this point, minus 900. Okay? Everything here is concave down. Everything here is nonlinear because everything here, of course, linear has to give you nonlinear under it. This is going to be nonlinear. It should give you also nonlinear. So we are here minus 900. Now we should be talking about, we should make the same cut. If you make a cut from the same way, like here, from the other side, eventually it has to go to 0 because here there's nothing, there's no moment. So eventually it's minus 900. And since we did it before, it's going to give you here a minus 900. Here, from the other side, it will give you plus 900. So plus 900 minus 900 will give you 0. Okay? So this is the shear moment diagram of this example. Hopefully that this is understood.